So this video is basically a more in-depth look at the connection between long division of polynomials and synthetic division of polynomials. So I'm going to do examples of both and on the same problem so you can see how they compare to each other. So here's an example of polynomial division I'm dividing x plus 3 into x to the fourth plus 3x cubed minus 4x plus 7. So if I'm going to do long division, I just write x plus 3 over here, and inside the division bar I'm going to put x to the fourth plus 3x cubed, and I'm going to put a little extra plus 0x squared because I'm recognizing there's no x squareds there, minus 4x plus 7. This little 0x squared maneuver is not imperative. You can do it without doing that, but I think it just helps keep things in the right order and everything in its right lines and stuff as you start doing this. So the idea of long division is since there's two terms in the divisor, I'm going to go over to the second term up here for my answer, and I'm going to ask myself, and I'm really focusing on getting the first term of this to match with the first term of the thing I'm dividing into. So I'm going to say what times x equals x to the fourth, and the answer is x to the third. So then I multiply x to the third times both of these terms. So x to the third times x to the third is x to the fourth, and those should match up exactly, or you haven't done it right. And then x to the third times 3 would be positive 3x to the third. Okay, then my next move is to subtract. So x to the fourth minus x to the fourth is 0, and 3x cubed minus 3x cubed is also 0. Okay? So now I'm going to bring, well, I can't really bring 0 down, right? So that means, I can bring 0 down, but that would be 0x squared minus 4x. And when I say what times x equals 0x squared, well, nothing, so I don't put anything up there. So then I go to the next one and say, okay, let's bring one more down. So what I really have here is negative 4x plus 7. And I say what times x equals negative 4x, and that would be, negative 4. Negative 4 times x is negative 4x. Negative 4 times 3 is negative 12. And then once again, we're going to, so this went down there, that went down there. We're going to subtract negative 4x minus a negative 4x is 0. And 7 minus a negative 12 would be like 7 plus 12. And that would be 19. Okay, so this says that my answer was x cubed minus 4, but I had a remainder of 19. Now normally when we're doing normal division, we would write this answer as x to the third minus 4 plus 19 over the thing I was dividing by. And that would be the answer. So if I'm dividing this polynomial by x plus 3, that would be my answer. Okay? So now let's do the same thing where you can see it with synthetic division. So synthetic division is like fake division, kind of. That's what synthetic means. It's a way to do it quickly without having to keep track of all the x's and stuff. So what I'm going to do is going to take this polynomial just as it is and do 1. I'm just writing the coefficients. Put a little box here, and the thing that goes in the box is the root that's associated with this factor. So in other words, what makes this factor equal to 0? So if I plug in a negative 3 in for x here, that'll make this factor equal to 0. So that's what I put in the box, is negative 3 right there. Okay, draw my line. And so the way synthetic division goes, we add 1 to whatever's below it. We get 1, then we multiply. Negative 3 times 1 is negative 3. Then we add, that'd be 0. Multiply, 0. Add, 0. Multiply, 0. Add, negative 4. Multiply, 12. Add, 19. And the last one's always the remainder. So Now in synthetic division, we know that this is x cubed because we've already done it, but if we didn't already do the long division, we knew that we started with an x to the fourth, so when I divide by a linear factor, I know that the next one, my first answer, my first coefficient is going to be x cubed. That would be 0x squared, that would be 0x, and that would be minus 4, with a remainder of 19. So you can see that doing the synthetic division produces the same result. And there's the 19 matching with that. It's a quicker way to shuffle the numbers around. Okay, let me do one more example. Let's say I want to divide x plus 2 into 3x squared plus 7x, no, let's say 3x to the third at least, plus 7x squared minus 4x plus 2. Okay. So doing long division, I say what times x equals 3x squared? That would be 3x. I'm sorry, what times x equals 3x cubed? That'd be 3x squared. Then I multiply 3x squared times x is 3x cubed. 3x squared times 2 is positive 6x squared. Then I subtract. That would just be x squared. Bring the minus 4x down. And I do the whole process again. What times x equals x squared? That must be plus x. X times x is x squared. X times 2 is positive 2x. And then I subtract again. X squared minus x squared is 0. Negative 4x minus 2x would be negative 6x. Then I bring the, what on earth is that? What did I say that was? A 2? Bring the positive 2 down. Then I say what times x equals negative 6x? That'd have to be negative 6. Negative 6 times x is negative 6x. Negative 6 times 2 is negative 12. And then I subtract 0, 2 minus negative 12, which would be 14. Okay, so then my answer would be 3x squared plus x minus 6 plus 14 over x plus 2. Now if we do the same thing as synthetic division, because this is x plus 2, I put negative 2 in the box, because negative 2, when I replace with x here, will make that factor 0. Then I'm going to put a 3, a 7, a negative 4, and a 2. Notice I didn't have to put any zeros in, because this already has x cubed, x squared, x, and no x, so that has all the powers in line. And so then I'm going to go ahead and do this, drop the 3 down. Negative 2 times 3 is negative 6. 7 minus 6 is 1. Negative 2 times 1 is negative 2. That gives me negative 6. Negative 2 times negative 6 is 12. And that gives me 14. So you can see the 3. So this again represents 3x squared, because I start with x cubed, plus 1x minus 6, with a remainder of 14 over, and that came from x plus 2. Right? So I can do this division using synthetic division as long as I remember what these things represent. Okay, now one more example. I do, for example, 3x plus 2 into 9x to the third plus 6x squared minus 12x plus 18. Okay? So I'm going to divide 3x plus 2 into that, and so I begin over here in the second term. What times 3x equals 9x cubed? That would be 3x squared. So I multiply, that'd be 9x cubed. 3x squared times 2 is positive 6x squared. I don't want to do that again. I don't. When the zeros show up, it makes it look like something special happened. Let's change this to. Let's change that to 9. Okay. Okay. So I'll get back to what I was saying. 3x squared times 3x is 9x cubed. 3x squared times 2 would be positive 6x squared. Then I subtract. 9x cubed minus 9x cubed is 0. 9x squared minus 6x squared is 3x squared. Bring the negative 12x down. I'm going to ask myself again, what times 3x equals 3x squared? And that would have to be plus x. So that would give me 3x squared plus 2x. And now I'm going to subtract. 3x squared minus 3x squared is 0. Negative 12x minus 2x would be negative 14x. And I bring that 18 down. And I ask myself, what times 3x equals 14x? And the answer would be, negative 14x. The answer would be negative 14 over 3. So negative 14 over 3 times 3x would be negative 14x. And negative 14 over 3 times 2 would be negative 28 over 3. And negative 14x minus negative 14x is 0. And this is going to be what? Let's see. 18 over 3 would be the same thing as 36, 40, 54. So this would be 54 over 3 plus 28 over 3. That would be 72 over 3. All right? Which, of course, is twice with 1 left over. So that'd be 24. Oh no, that's not right. I did that wrong. 54 plus 28 would be 82 over 3. Yeah. So that'd be 82 over 3. There we go. Okay. So now let's do the synthetic division. I'll do it right down below here. Now here's the trick. To do synthetic division, remember we put the number that would make that factor equal to 0 in there. And what makes this expression equal to 0 would be negative 2/3. All right? So, but now watch what happens. When I drop the 9, negative 2/3 times 9, 3 and the 9 will cancel, leaving a 3, so that'd be negative 6. Negative 6 plus 9 is 3. Negative 2/3 times 3 would be negative 2. Negative 2 plus 12, or negative 12 plus negative 2 would be negative 14. And then negative 2/3 times negative 14 would be positive 28 over 3. Add those two together and I get 82 over 3. So notice that the remainder is the same, but the numbers are off. So up here I have my coefficients are 3, 1, and negative 14 over 3. Here my coefficients are 9, 3, and negative 14. So, but we do notice that they're off by a factor of 3, because if I multiply everything in here by 3, I will get this, or if I divide each one of these by 3, I would get that, right? So we're saying that, and the difference is what I'm doing here, remember, is I'm dividing x plus 2/3 into 9x cubed plus 9x squared minus 12x plus 18. That's what I'm doing. And what I really wanted to do this. And so you can see why these numbers are different, because it's going to take, if I was trying to get this to match up with that, I'd have to start off by multiplying by 9x squared. Rather than here, I'm multiplying by 3x squared. And so the cool thing is that I can still do this problem using synthetic division as long as I remember I need to adjust my answer. So if I was to just do this without looking at that synthetic division, I would have got an answer for like this, and I would have said the actual answer to the problem I want is 3x squared plus 1x minus 14 over 3. So I just divide all my coefficients by 3. Why am I divided by 3? Because that's the number that's the coefficient of the lead term in my divisor, the thing I'm divided by. Okay? So that's a little rundown on synthetic division. Oh yeah, we'd finish this off by going minus plus 82 over 3 times, what was it? 3x plus 2. 3x plus 2. So actually be 3x squared plus x minus 14 over 3 plus 82 over 9x plus 6.